Welcome everyone to our new subtopic under place value system. We'll be treating addition and subtraction. In our early learning days, we were taught arithmetic pattern of arranging whole numbers in thousand, hundred, tens, and unit. For instance, 3425 is same as we write out our thousand, hundred, tens, and unit, and we carefully insert the 3 under 3000, 4 under 100, 2 under tens, and 5 under unit. But as we proceed to the beginning of secondary classes, we are required to apply the knowledge of place value system without necessarily showing the thousand, hundred, and unit. Let's take some examples. I find the sum of 3520 and 79. I the sum of 1429 and 6580. I the result of 60 plus 197 plus 3 plus 8001 is IV, which is 4. The difference between 6203 and 97 is solution. You may say it is simple addition and subtraction, but let us look at a different solution given by students. First, we take our I, which is sum of 3520 and 79. Student A approach, he wrote 3520, but he arranged the 79. He put 7 under 3, 9 under 5. And in giving the result, he added 0 will be under 0. He brought 2 down. Then 5 plus 9 gave him 14 and he carried 1. Added to 3 plus 7, which is 10, then plus 1, which is 11. But he just left the 1 there. He was confused. Student B approach. He wrote out the 3520 as usual, but in placing 79, he placed 7 under 5 and 9 under 2. And in adding the result, he brought his 0 down. Then 2 plus 9 gave him 11, and he just wrote down 1 and carried 1. 5 plus 7 gave him 12 and added 1 to it, the one he carried, and make it 13. Put his 3 down and carried 1 to add to the 3 this last, and wrote 4 down. Yes, it's working. Methodology of working is okay. But his placement of the value, the result, we'll look at it. Student C approach. The student wrote out his 3520 and placed 7 under 2 and 9 under 0. Now, in adding his values, 0 plus 9 gave him 9, and 2 plus 7 gave him 9. He brought down the 5 and brought down the 3. Only student C working is correct because he or she obeyed the rule of thousands, hundreds, tens, and units, which we learned in arithmetic. Yes, we continue with our solution. I, that is sum of 1429 and 6580. Let us look at how the different student approached it. Student A, he wrote out his 1429 and placed 6 under 4, 5 under 2, 8 under 9, and 0 was placed a little bit outside. And in adding the values, his result became, he brought his 0 down. Then 9 plus 8 gave him 17, and he wrote the 7 down, carried 1. 2 plus 5, which is 7, plus the 1 he carried, he wrote the 8 there. 4 plus 6 is 10, wrote 0 down and carried 1. 1 plus the 1 that is there, 2. It's methodology. It's okay, but the arrangement, we will give the judgment when we are through. Student B approach. Wrote out is 1429, but in placing the second value under it, he wrote out is 6 outside, then place 5 under 1, 8 under 4, 0 under 2, then 9 was outside. And in adding those values, the result was this. 9 was brought down, 2 plus 0 gave 2, 4 plus 8, which is 12, put 2 down, carry 1. 1 plus 5, which is 6, plus 1 he carried, gave 7. Then he brought down the 6. Methodology okay, for the result. Student C, in his approach, 1429 was written out, and the arrangement, 6 was placed under 1, 5 was placed under 4, 8 was placed under 2, and 0 was placed under 9. And the result was this. 9 plus 0 gave 9, 2 plus 8 gave 10, 1 was carried in the 1, 4 plus 5 gave 9, plus the one that was carried, 9, it became 10. 0 was written down and 1 was carried. Now 1 plus 6 is 7, plus the one that was carried become 8. Only student C did the correct working. Since he knows that both numbers are thousands, both numbers are in thousands, hence no need for unnecessary shifting of positions. I. Sum of 60 plus 197 plus 3 plus 8001. The arrangement, space will not allow us to show you what some of students wrote. It is better imagined. The rule of thousands, hundreds, tens, and units must be followed, even though it is not written directly whenever we are doing our addition or subtraction. The right arrangement, we are given 8001, then 197. 1 is placed under 0, 9 is placed under 0, then 7. Then 60, 6 is placed under 9, and 0 is placed under 7, then 3. In addition, 1 plus 7 plus 3 give you 11. 1 is written down and 1 is carried. 9 plus 6 is 15, plus the one that is carried, 16. We write 6 down, carry 1. Plus the one that is there become 2, and 8 is brought down. IV, that's 4. The difference between 6203 and 97, we are presented as student A. 6203, 9 was placed under 6 and 7 was placed under 2. We are arriving at the solution. Since this is subtraction, he brought his 3 down, 0 down. Subtracting 7 from 2, he borrowed 1 from 6 to 2 and it became 12. So 12 minus 7 give you 5. Now to subtract 9 from the remaining number which is 5, there became an issue. So he left it unattended to. Student B approach. Wrote out 6203, then place 9 under 2 and 7 under 0. In subtracting, since this is subtraction, he brought down the 3. Now 0 minus 7 cannot. He borrowed 1 from 2 and placed there. So 7, it becomes 10. 10 minus 7, 3 was accurately done. Then you are left with 2, 1, which 2, you already borrowed 1 from there, so you are left with 1. When he wanted to subtract 9 from 1, cannot. He borrowed 1 from 6 and placed there. Became 11. 11 minus 9 is in 2, and he brought down the leftover 5. Student C wrote out 6203, and 9 was placed under 0, 7 was placed under 3. In subtracting, 3 minus 7 cannot, so 1 was borrowed from 0, which cannot. So he borrowed 1 from 2, place it at where you have 0, become 10. So he borrowed 1 from that 10, and the result become 13. So 13 minus 7 gives you 6. Remember, we are now having 9 in the next position where you have 0. So 9 minus 9 will give you 0. Already 1 has been borrowed from 2, so you are left with 1 there. Brought down the 1, placed there, and 6 was brought down. Student A ran into problem of where to carry from to add to 5 so as to subtract 9. Hence, he left his work uncompleted. Student B was trying to be smart, but in the wrong direction. His arrangement did not obey the rule of thousand, hundred, tens, and unit. Only student C arranged his work properly and got the right answer. Yes, we've come to the end of the examples of this subtopic, which was taken from our hidden fact in GSSC Mathematics, page 1. Yes, our learners, we can try our hands on the exercises that are given below. Place value arrangement in decimals. In this subtopic, earlier on we have treated addition and subtraction, whole numbers, and we show how the arrangements are done. The aspect we are treating now has to do with decimals. We'll also be showing how the arrangements are done. Let's take some examples. Solve 80.7 minus 30.46. Solution. Proper arrangement. We shall present our answer side by side. We have proper arrangement and proper presentation. Proper arrangement, we write out our 80.7 as given, and we now write 30.46 under it. But the 4 will come under 7, and 6 will be a little bit outside. Now, in our proper presentation, we will write our 80.7 and we introduce 0. Then we now write our 30 under 80, then 0.46. Here, remember we are dealing with minus. The question says we should subtract. So 0 minus 6 cannot. We borrow 1 from 7 and it becomes 10. So 10 minus 6 comes 4. Now we are left with 6 there in the place of 7 because we have borrowed 1 out. So 6 minus 4 becomes 2. We put our decimal point. Then 0 minus 0 is 0. 8 minus 3 is 5. Let us take note. The 0 added after our 80.7 means nothing. But don't add any of the numbers 1, 2, 3 up to 9, as this means something else. We change everything about your solution. Let's take another example. Solve 115.06 minus 22.2. Solution. We have our proper arrangement and proper presentation, all side by side. I will write out our 115.06 under our proper arrangement. Then we'll put 22 under 15.2. 2 will be under 0. That is our proper arrangement. But in proper presentation, this is how it ought to be. 115.06. Then we put our 22 under 15. That is 115.20. We are introducing 0 there for proper presentation. Then we now do our subtraction. 6 minus 0 will give you 6. 0 minus 2 cannot. So we borrow 1 from 5 and introduce it there. That will become 10. So 10 minus 2 will give you 8. Point. Remember, the place of 5 has now reduced to 4. So 4 minus 2 will give you 2. The next, you have 1. 1 minus 2 cannot. So you borrow 1 from the other one that is standing, and that becomes 11. So 11 minus 2 become 9. 0 was introduced under our proper presentation after 2. Since the decimal point is there, the 0 does not mean anything. We have earlier been warned that we should not introduce any other number other than 0. Another example. Add 0.03, 51.4 and 2.003. Solution. Our proper arrangement and proper presentation will be given side by side. Now, the examiner in this question want to know whether you can arrange these given values properly. So we start with 51.4, then we introduce 2.003, then we introduce 0.03. Note how it was properly arranged. Then in our presentation, we write 51.4, then we introduce 00 after decimal. 0 after decimal, when a number has been given, does not imply anything. So plus We are introducing our 2.003. Then we also write out our 0.03. Then we introduce 0. Now, if you look at what we have done, we have not done any harm to the system of what we are giving. In as much as the 0 that we introduce, we are after a number and behind decimal. Now we can conveniently do our addition. 0 plus 3 plus 0 is equal to 3. 0 plus 0 plus 3 is equal to 3. 4 plus 0 plus 0 is equal to 4. 1 plus 2 plus 0 is equal to 3. Then we bring down our 5, and that is our solution. Another example. What is the sum of 12.41, 120, and 0.426? The options are given. A, 162.386. B, 152.306. C, 142.386. D, 132.846. E, 132.836. Solution: proper arrangement. In our proper arrangement, we write 120, then we put our 12 under 20.41. Then we introduce our 0 point, then 426. If you look at the work carefully, you can see how we are carefully doing our arrangement. Now, the proper presentation will be that we write our 120.000 to fill in the gap. We have not done any harm to the system. Then we write our 12.41, then we introduce 0. It's after decimal. So we have not done any harm. Then 0.426. We do our addition. 0 plus 0 plus 6 is equal to 6. 0 plus 1 plus 2 is equal to 3. 0 plus 4 plus 4 is equal to 8. Then we can proceed to the whole number side. 0 plus 2 plus 0 is equal to 2. 2 plus 1 is equal to 3. Then we bring down our 1. And that is our solution. Yes, we have come to the end of our examples under this subtopic. We'll be taking exercises so that you can try your hands on them. The exercises and the examples are taken from our book, Hidden Fact in GSSE Mathematics, page 1 and 2. Thank you.